Before you start screaming at me about the thumbnail, just have a look at these 8 essential laws for powers which might solve your question. So indices and powers only exist with another number. They show how many times a number will multiply itself. For example, a 2 as the base with a power of 3 means that 2 will multiply itself by 3 times. Unfortunately, the stuff with powers does not end here. There are 8 laws on powers that we need to learn about. Firstly, if you multiply the same number that is raised to different powers, just add the powers together. Think about it. Powers tell you how many times the base multiplies itself, and multiplication of 2 powers with the same base is just combining the repeated calculations. To visualize it, a to the power of 3 times a to the power of 2 equals a to the power of 5. This is because a to the power of 3 equals to a times a times a, and a to the power of 2 equals to a times a. If we expand out the powers, we get this, which is just a multiplying itself 5 times, making it a to the power of 5. Secondly, if you divide the same number that is raised to different powers, subtract a power. It's the same logic as the first one. Division of 2 powers is just cancelling out matching factors, meaning you'll be left with the difference in powers. For example, a to the power of 5 divided by a to the power of 3 equals a to the power of 2. If you expand the powers out, you will get this. And because multiplication and division are inverse operations, times a and divide a can cancel out each other. This will leave you with a multiplying itself 2 times, which makes it a to the power of 2. Thirdly, if you place a power on a base that already has a power, just multiply the powers together. Don't forget powers cause a number to multiply itself. And if you apply a power to a power, the number will just multiply itself with the first power, then move on to the second power. For example, a to the power of 3 to the power of 2 equals to a to the power of 6, as what we are doing is just a to the power of 3 times a to the power of 3, which will just give us a multiplying itself 6 times, which is a to the power of 6. Fourthly, any base to the power of 0 equals to 1. This one we can use our second rule as reference. A to the power of 2 divided by a to the power of 2 equals to a to the power of 0, as the difference in powers of 2 bases is 0. However, we need to remember that any number divided by itself is always equal to 1. In this case, a to the power of 2 divided by itself makes a to the power of 0, meaning it equals 1. Fifth one, any base to the power of 1 equals to itself. Very self-explanatory. The base only multiplies itself by once, which means it stays the same. So a to the power of 1 equals a. Nothing changes because there's only one copy of the base, so no repeated multiplication happens. Sixth one, if the base number is the whole fraction with the power outside of the fraction in a bracket, then the power should be applied to both the numerator and the denominator. The reason here is the whole fraction is multiplying itself, thus both parts of the fraction should also follow. Examples can be 2 over 3 to the power of 2. You are doing 2 over 3 times 2 over 3, so it's basically 2 to the power of 2 over 3 to the power of 2. The last 2 laws require a bit more brain cells. Seventh law, when you apply a negative power to a base number, it becomes reciprocal of the base raised to the positive power. In other words, a to the power of minus n equals 1 over a to the power of n. Again, take the second law as a reference. A to the power of 2 divided by a to the power of 3 equals a to the power of minus 1, as 2 minus 3 equals to minus 1. But if we put this onto a fractional view, where a to the power of 2 is the numerator and a to the power of 3 as the denominator, we will see that 1a will be left on the denominator after simplification, which gives us 1 over a. Therefore, a to the power of minus 1 is the same as 1 over a. And the final one, when a power is a fraction itself, the numerator of the power is the power, but the denominator of the power is the root. In other words, it can look like this. For reference, a root is the exact opposite of a power. A root of a number is another number that when multiplied itself by a certain number of times gives the original number. This law works as if 2 square roots of a are multiplied together, it gives you an a. And because a itself has a power of 1, it means that the square root of a has a with a power of a half. From the first law, when you multiply 2 numbers with the same base, you add up the powers. This means a to the power of a half times a to the power of a half equals a to the power of 1, which equals to 2 square roots of a multiplied. Simplifying this, and we get a to the power of a half equals square root of a, which proves our final law and our thumbnail. For the second part of the video, we'll have a look at standard form. This refers to writing numbers using powers of 10. The standard form contains 2 parts. One is a number from larger or equal to 1 but smaller than 10, which will be multiplied by the second part, 10 to the power of something. In order to find the standard form of the number, we just have to move the decimal point of the number until the decimal point causes the number value to be between 1 and 10. Then, based on the movement of the decimal point, it will determine what the power of 10 will be. If you move the decimal point to the right by one number, it will be 10 to the power of minus 1. If you move the decimal point to the left by one number, it will be 10 to the power of 1. Take this as an example. For numbers that don't explicitly show a decimal point, this decimal point is at the right end of the number. So in this case, we'll want to move the decimal point to the right while counting the amount of numbers it went through. If you did it right, you should end up with the decimal point between 5 and 7, after it moving to the left by 5 numbers. Therefore, the standard form of 570,000 will be 5.7 times 10 to the power of 5. Finally, for calculating numbers in standard form, you can surely expand the standard form back to its ordinary form, but it will be very annoying as you are likely to be asked for a standard form answer. So the only suitable way for this is to convert the numbers into the same power of 10. Before we move on to the example, just remember this. Multiplying a number by 10 will decrease the power of 10 by 1, and dividing a number by 10 will increase the power of 1. Inverse operation stuff, as decreasing power is just division and increasing powers is just multiplication. More about this on the right hand corner. But right now, we can have a look at this example. You can convert either of the numbers, but what I will usually do is to convert the number with a larger power of 10. This is to prevent any existence of decimals, which will just make the calculation harder. In this case, we want to convert 10 to the power of 6 to 10 to the power of 4. This means we want to decrease the power of 10 by 2. As a result, we have to multiply 3 by 10 to the power of 2 to balance out the decrease in power to maintain the value, giving us 300 times 10 to the power of 4. Now we can do subtraction. As both numbers have the same power of 10, we can just ignore them and add the numbers up. So 300 minus 4 equals 296, giving us 296 times 10 to the power of 4. Sadly, this is not exactly standard form as the number of it has to be between 1 and smaller than 10. So we will have to convert it back. In this case, we will want to divide 296 by 100 to make it between 1 and 10. Then we will have to increase the power of 10 by 2, which is basically multiplying it by 100 to balance out. So finally, we will end up with 2.96 times 10 to the power of 6, which is our final answer. Afterwards, for multiplying and dividing numbers, all you have to do is to separately multiply or divide the numbers in a standard form. Just having an example to make sure you get it. For this one, we just do 3 times 4 first, which gives us 12. Afterwards, for 10 to the power of 5 times 10 to the power of 4, we get 10 to the power of 9, as multiplication of base could be done by adding up its power. We then combine both results back for 12 times 10 to the power of 9, but that's not it. We divide 12 by 10 to get 1.2 and multiply 10 to the power of 9 by 10 to get 10 to the power of 10, which gives us the exact standard form of 1.2 times 10 to the power of 10. And that's it for this video. More videos up here. Don't forget to subscribe, and I will see you on the next one.